Greetings! Today I was in Ikea buying something, and as it turns often out in Ikea, you end up buying lots of stuff that you never knew you wanted in the first place. So I came across this. This was on clearance, and I couldn't resist to pick this up. This is Ansluta. It's a remote controlled dimmer. A remote control dimmer switch, and it was on clearance 50% off, so I got a couple of those because if it's a remote control dimmer, even if I haven't got an immediate use for it, I will find one because that's quite handy. But yeah, I thought I'll make a quick video because I'm keen to see what's actually inside. So we'll have to take it apart. Of course, we've got the two pieces and the usual recycled paper instruction manuals, which I won't bother with at the moment, and the remote is separate, and we've got the switch unit, and it's got connections. This must be the input for the 240 volts, and this has got the little flaps, so it's protected. You can't poke a screwdriver in immediately by accident, so this will be the output, and it's 100 to 240 volts AC, 2.5 amps. So yeah, it will switch 600 up to 600 watts at 240 volts. So okay. Receiver category class 3, double insulated, so it doesn't require ground connection. Good, because it hasn't got one. The F symbol, I didn't know. I looked it up. It actually means that this can be mounted on flammable surfaces such as wood. So you can screw this using the screws provided to the wood, and it's not going to get hot enough to cause ignition. And some Intertech China export and some other usual stuff. So yeah, I thought it would be interesting to take this apart and see what sort of switching and communication it does with the remote. So let's take it apart. Let's begin with the remote, because that's going to be quicker, and this just unclips with just a screwdriver, and we've got some space for two AAA batteries, two switches for up and down, a status LED in the middle, which I guess blinks. We've got 4 megahertz oscillator, or a filter, maybe that is. I'm not too sure. And the quartz is 13.56 megahertz. And two little chips on here. Let's put our lens on here. Oh, that's better. So we've got a Holtec branded chip, HT48R08A. It's not very visible, and that's better. HT48R06A-1, and this what appears as a filter, maybe, or a crystal, I'm not too sure. And on the other side of the board we've got another Holtec HT9831, so, and a bunch of passives, just caps really, and maybe a couple of inductors or a couple of resistors. So let's get at the business end box, and this is going to be a little bit more trickier. So this, I hope it hasn't. It doesn't look like it's been glued in. It's got that little gap, so I'm quite sure it's been screwed in, and you can see faintly there is screw holes in 4 corners. So they've been blanked out, so just so no one can get at it. So I guess we're gonna have to poke our way through it. Well, this is not immediately obvious how to get at it. Ah, there we go. Yes, we've got a security screw, tri-wing Phillips style, and those caps are really long, but that's okay. This is a really cool gadget. I'm not sure why are they discontinuing it. I mean, if you can use so many things with it. I mean, 600 watts is a decent amount of power, and the fact that you can dim it, depending on how the dimming is done, this can be used for many things, like speed control on a motor. Although that'll be interesting how it survives with a high inductive load, because that might prove to be very difficult to drive. It might get killed actually if you plug in like a maybe angle grinder or a drill to it, but that's yet to be tested. So let's put those aside, and I need to pull out my other set of screwdrivers because I need this. So a tri-wing Evil. Why are they doing this? I mean, if someone wants to take it apart, they will anyways. I'm just... But maybe because they are using somewhat non-standard screws, your usual average person... I always thought I'm quite average, but yeah, I just seem to like screwdrivers, but it seems like they think that no one's gonna bother with unscrewing it because the only Phillips screwdriver that they have is not capable of getting this undone. The last one doesn't want to come out, no problem. And we're in. So let's maybe put this put those aside, and normal screws over here. Now it's worth noting, horrible soldering, absolutely horrible. So you can see it's full of flux all over the place, and yeah, I did see better. Standard Phillips inside, so no problem here. Once you're in, you're in. Oops, springiness. Something's going to pop out. Oh, that's the spring. Spring is the antenna. Ha! How about that? Okay, so we've got a switch over here, status LED, a relay. Okay, so this is not a dimmer. This is not a dimmer, this is on-off switch. Okay, oopsies, but still I'm gonna find a use for it. There's another Holtec chip. We'll look at that in a moment. And what we've got a few caps. So how is this working? So we've got the two plugs. Those are completely going in. So isolation between the mains is great over here. I mean, at the shortest, the smallest gap anywhere is roughly about, I don't know how much is that, 7-8 mil. So it's quite a lot. There is no slots cut out, which could be a little bit better. But in terms of AC, when it goes where it goes in, it literally I can see the neutral, the blue. Well, those plugs are kind of polarized if you use the Ikea supplied plug. So I guess this would be the neutral, and that goes into the center pad, which doesn't really go anywhere. It goes straight across to the other one. So I will be rewiring this anyways, because I haven't got the matching plugs for this, so I need to just take note of the neutral connection in the middle. Now in terms of live, so as I suspected, this is the input. Now the output goes straight from the relay onto the output, and that's all there is to it. Now in terms of input, the AC goes here, goes through the fuse that's mounted in a little holder, and across from the fuse it goes two places. So one goes to the relay to be switched over to the output, and another bit goes through this resistor, big heavyweight resistor, onto the caps. There is a 470k resistor across the caps. Those are X2 caps, so the proper mains rated caps. 100 microfarad, that's somewhere else. Okay, we'll get there. And okay, we've got a little bridge rectifier. There is a space for a MOV over here, for a varistor, but but it wasn't fitted in this this version. So okay, but anyways, after the caps, are those in series? Let's go. Yeah, so those two caps are just current limiting caps, and from here it goes through a bridge rectifier, tiny little one, and there is this cap just to smooth it out a little bit, another smaller cap across it. Now there is a diode over here. What is that doing? That's strange. So there is a bridge rectifier, and from the negative output of the bridge rectifier, there is a diode with anode connected to the negative and cathode, going through to here, and then through a, what is that, 100 ohm resistor to the negative. So I'm not sure what that's doing, but okay, I guess it should work, I presume. Let's put our lens back on. There we go. So there is another chip which is horribly soldered. There's a lot of stuff on here. Oh, that's better. So that doesn't look like Holtec anymore. 480R 731322. 480R 1322, whatever that means. 6.7458 megahertz oscillator, and it just goes to a spring thing to serve as an antenna. So this is the receiver bit, and this is simply, oh, there is no another chip over here. How about that? And this one's Holtec HT48R06A-1. I think that's the same one. This might be a micro, you know. I think the smaller chip, this one and this one, yeah, this and this, those are probably dealing with the transmission of and receiving of the signal, so remote control. And the bigger Holtec over here is a micro, most likely, that they've done. There's another Holtec 2201, probably some voltage regulator. What this probably does is takes care of it's a low power, probably just low power micro with just controls the data received from the radio, and blinks the LED and monitors the switch. So if you click the switch, it happens. So the whole thing is done in a little micro. There's a lot of unused pins on this, so you can see they haven't used it to its full potential. It's probably just a cheapo microcontroller, and yeah, that's all there is to it. 78L05, yeah, 5-volt regulator to give it 5 volts, and that's it. A little transistor is driving the relay. Hold on, losing focus. There we go. It's a 24-volt relay. I think they've purposely used the 24-volt relay, even though it's probably not getting full 24 volts. But what's happening with a higher voltage relay, the coil, the electromagnet inside has got a little bit higher resistance, so it doesn't draw as much current, which as for example a 5-volt or a 12-volt relay. But in this case, because they're using a capacitive dropper power supply, drawing too much current would cause the voltage to drop drastically. So, and they can't just put a bigger cap, because then when the relay is disengaged, the voltage would be too high, and it would burn out the 78L05 or something else on the board. So you have to use a higher voltage relay, and even though it's 24 volts, it will probably work with even 12 or 15 volts, and that's probably more or less what's coming out of the output over here. So yeah, that's I'm a little bit disappointed that it's not a dimmer. I wasn't paying attention to it. But I thought you can just switch up and down, press and hold it, and maybe there was a triac or something switching the AC, but it's not. It's just a relay, which is still okay. I could still make a use of that. But yeah, that's it for this quick video and a teardown. A look inside Ansluta Ikea remote controlled switch. Hope you enjoyed it, and yeah, subscribe for more random stuff. For now, take care.